Hi, science enthusiasts. My name is Cavell Hilton.
And I am Lydia Hall.
And welcome to another exciting episode of our STEM Virtual Experiment series, where we share new concepts and explore the remarkable world of science, technology, engineering, and mathematics, STEM for short.
Today, we will be conducting an experiment called Multicolored Flames, Fireworks, where we will be demonstrating how different elements are able to produce different colored flames.
Wow, sounds exciting. Fireworks, you say? You know, I've always wondered how fireworks are able to produce those many different colors.
Really?
Yeah, and I'm sure our viewers at home can recall seeing fireworks this year. Maybe they can remember all those blues, oranges, yellows, and purples exploding in the skies, creating those oohs and ahs. You know what would be interesting, Nisha?
What, Cavell?
If we're able to figure out what's behind those brilliant colors. And I'm sure you will explain.
Of course, Cavell, I'll gladly explain. The colors in fireworks are based on a simple concept, pure chemistry. They are made by using metal salts to create these spontaneous, intense colors. Metal salts are produced essentially by exchanging the hydrogen in acids with metals. That's in theory. But in practice, what we do is incorporate metal oxides into acids. So in the production of fireworks, there is also the use of potassium nitrate, sulfur, and charcoal in helping the fireworks to burn. They also use percolates, chlorates, and nitrates to produce or to help make available the oxygen necessary for the combustion process. And then there is use of dextrin to keep the mixture together.
So in essence, different salts produce different flames.
Exactly, Cavell. So today we'll be seeing some blue, oranges, violets. Are you ready?
I'm ready. How about you guys? So are you guys ready? Let's do this. So for this experiment, we will need some metal salts. So we have lithium hydride, potassium chloride, copper sulfate, sodium chloride, barium chloride, and of course we have some ethyl alcohol, which we will use to create the flame. So we also have some aluminum cans and of course matches. But I'd want to caution you at home, do not try this at home. Be very careful, okay? So the first thing that we're going to do is we are going to add some lithium hydride to our aluminum container. And then I'm going to add some potassium chloride, not to it, but to its own container. And you notice I'm using a spatula for each so as to prevent contamination. Okay. Some sodium chloride here. And finally, some barium chloride. Then I'm going to add some ethanol to each. And I'm adding about the same amount to each salt because No, that's important in science. All right, so are you ready to see some fireworks? So let's start with our lithium hydride. Now, lithium hydride is expected to produce a pretty pink red flame, which we can clearly see from this experiment. Brilliant, isn't it? Now I wonder what color we will get from the potassium chloride. So the potassium chloride is expected to produce a violet or dark pink color, which is much different from what we'll see for the lithium hydride. Okay, there you go. All right, let's see what will happen for the copper 2 sulfate. Oh, that's brilliant. So the copper 2 sulfate produces a blue-green color, which you can clearly see here. Wow, that's awesome. Pretty exciting. Wow. Let's try sodium chloride. Wow, we can still see those blue-green colors coming out of the copper 2 sulfate. And the sodium chloride, let's see what color it will produce. This one is awesome. And you see this, guys? See, as the flame dies down, you actually can see even more of that blue-green color. All right, and so for the sodium chloride, we're looking for a yellow-orange color, which would probably be a little bit more difficult to see considering the color of the flame itself. All right, and then finally, we're going to try and see what happens with the barium chloride. All right, so the barium chloride is supposed to produce a yellow-greenish color. So of course, we want to keep the alcohol away. So looking for those yellow, beautiful, yellow, brilliant flames. Awesome. There you go. Great. Now, Ligia will give you some further explanation as to why we were able to observe the different color changes in these different salts.
The experiment follows the basis that each chemical element has different energy levels, and based on the excitement of the electrons on the orbits of the atoms, they are able to emit various colors because the electrons moving around the nucleus have different energy levels. When you have lower energy levels, you will see flame colors that are towards the red end of the light spectrum, so red, orange, yellow, and so on. On the other hand, higher energy levels produce colors that are more on the blue end of the light spectrum. These will be blue, green, purple, and so on. Incidentally, the closer to the blue end of the spectrum your flame colors are, the hotter the flames will be. The very hottest of flames will appear to be white. In the case of this experiment, the chemical elements in the flame will also manipulate the colors of the flame. If you excite an atom or an ion by very strong heating, electrons can be promoted from their normal unexcited state into higher orbitals. As they fall back down to lower levels, either in one go or in several steps, energy is released as light. And we know that light energy is termed photons. Each of these jumps involves a specific amount of energy being released as light energy, and each corresponds to a particular wavelength or frequency. As a result of all these jumps, a spectrum of lines will be produced, some of which will be in the visible part of the spectrum. The color you see will be a combination of all these individual colors.
That was a brilliant explanation, Ligia.
Yes, Camille, thank you.
Awesome. Now, who do you think? Do you think there are other things that will burn these unique colors?
Possibly.
What would happen if we were to mix the different ingredients? A new color, maybe?
Maybe.
Ah.
How do you think this information can help you in real life? Comment below with your answers and with some prizes.
Awesome. And remember to subscribe, like, and share.
Thank you for watching.
And see you next time.
Bye.